So good day class and welcome back to another challenging exercise. So in this question is asking in an audio CD, the audio voltage signal is typically sampled about 44,000 times per second. Just to give you a good idea of this, so imagine this is the time, this is the signal waveform, and this is 1 second. This thing is sampled 44,000 times in just this 1 second. So this is a good idea of the graphical look of what this is. And the value of each sample is recorded on the CD surface as a binary number. It means this one sample is saved as a binary number. This other one is saved as another binary number. This one is saved as another binary number. So you get all the way to 44,000 samples. And they're all saved as binary numbers. Now, in other words, each recorded binary number represents a single voltage point. This is one voltage point, another voltage point, another voltage point, and so on. Now, the question is asking if the binary numbers are 6 bits in length, that is, the binary number used to save this sample is 6 bits in length. So that's 1, 2, 3, 4, 5, 6. It's 6 bits in length. So to save one voltage sample, you're using a 6-bit binary number. How many different voltage values can be represented by a single binary number? So the key word here I want you to notice how many different voltage values. This question is actually asking if you're using a 6-bit system to store these samples, you're going to have the lowest one will be 0, 0, 1, 2, 3, and the highest one will be 1, 1, 1, 1, 1, right? And all the values in between 0, 0, 1, 0, 0, 0, 0, 1, 0, all the way till you get to this, the highest value you can store. It's asking how many of this how many 6-bit values can, or rather, how many values can be stored with a 6-bit binary number. So we can obviously not keep physically writing these things all the way till we get the highest. So the easiest way to just do is 2 raised to power 6, which we get as 64. It means we can express 64 different voltage values if we are using a 6-bit. And they say repeat the same for an 8-bit and a 10-bit. It should be the same 2 raised to power 8. 2 raised to power 8 is 256. So we can, if we're using an 8-bit binary number to save our digital samples, we can save up to 256 voltage values. And for 10 bits, just choose per 10, which you get as 1024. So that means we can represent 1024 different values if we're using a 10-bit system. So that's it for the A question. Now for the B question, it's asking if the 10-bit numbers are used, okay, so now we're no longer using 6, we're using 10. How many bits will be recorded on the CD in 1 second? So now we know that in 1 second, 44,000 samples are taken. And each of these 44,000 samples are saved as a 10-bit binary number. This sounds like a multiplication problem to me. So to find the total number of bits that will be recorded in this in 1 hour, just be 44,000 times 10. As you get 440,000. So for the C question, if a CD can typically store 5 billion bits, how many seconds of audio can be recorded when a 10-bit number is used? So now, we know that if you're using a 10-bit system, in 1 second, you're going to have 440,000 bits. We got it from the previous question. Then how many seconds for 5 billion bits? This cross multiplication. So make x subject formula. We're going to have 5 billion, that's times 10 raised to power 9 divided by times 1 divided by 440,000. Punch this in your calculator, you're going to get this 0.64 seconds. So therefore, we have answered this C question. We can record 11,364.64 seconds in this storage of 5 billion bits if we are using a 10-bit number system. So that is all for this exercise. I hope that we have learned something and we understood. Thank you for listening.